There is a pervasive belief that when we hand a decision over to an algorithm, we strip away human emotion, bias, and politics to reveal pure, objective mathematics. For centuries, institutional decisions were made across a desk. A loan officer or public official weighed your case through direct conversation, relying on local context, personal reputation, and tacit knowledge to gauge risk. As organizations scaled, that human friction became a liability, and we built automated systems to replace the human judge. Yet these machines do not actually eliminate subjective choices. They merely relocate them. The judgment moves upstream, into the quiet rooms where engineers select the features and design the models, and downstream into the narrow workflows of exception handling. Algorithms are not neutral arbiters of truth. They are digitized, highly organized expressions of an institution's risk appetite and managerial power. If these systems aren't perfectly objective, we have to ask why massive banks, governments, and corporations are so eager to hand them authority. The answer comes down to operational volume. Manual bureaucracy eventually hits a breaking point. A lending department or a tax authority simply cannot process millions of paper files using human review without massive delays and prohibitive costs. Institutions adopt machine decision-making to satisfy three relentless economic demands: speed, scale, and standardization. In a digital economy, thoughtful, localized deliberation is viewed as an intolerable bottleneck. A trading floor relying on human shouting cannot compete with a system executing thousands of orders in a fraction of a second. The shift to automation is an operational bargain. Organizations permanently trade contextual richness and nuance for administrative control and infinite scalability. To see exactly where human subjectivity enters the code, we have to deconstruct the logical anatomy of an automated decision engine into its three stacking layers. The first layer is rules, deterministic logic creating rigid thresholds. If X, then Y. The second introduces models, using probabilistic mapping to estimate relationships and assign percentage probabilities. The third is the algorithm, the execution logic processing millions of inputs simultaneously. Guiding all of this is the objective function. It is the specific mathematical target the algorithm is commanded to seek, such as maximizing revenue or minimizing default rates. Selecting this target is a deeply political choice. If an institution optimizes a logistics network purely for absolute cost reduction, it intentionally strips away spare capacity, destroying the system's resilience to external shocks. The foundational logic of any automated system is built entirely on human assumptions about what matters most to the institution. These models run on vast amounts of data, but machines cannot observe human motives, local context, or lived reality directly. To be processed at scale, subjects must become legible to the machine. A person or a business must be translated into standardized, rigid formats. Years of tacit knowledge and relationship building are compressed into flattened, machine-readable transactional traces. Because abstract traits like diligence or trustworthiness cannot be computed directly, systems rely on proxy variables. Proxy variables are measurable data points used as stand-ins for unquantifiable traits. A system uses debt ratios, postcodes, or employment duration to estimate reliability. Elements resisting quantification, a temporary hardship, strong local reputation, or informal work, are structurally sheared off, erased entirely from the system's vision. Data is never a perfect reflection of reality. It is a highly curated representation, built strictly for institutional convenience. Because probabilistic models output risk percentages rather than certainties, they contain inherent statistical uncertainty. A human engineer or manager must manually set the specific numerical threshold that converts a probability into a hard action. This chart shows the inescapable trade-off between error rates, balancing false positives, flagging non-existent problems, against false negatives, missing real ones. Terrified of regulatory fines for missing a crime, a bank's anti-money laundering engine is strictly optimized to avoid false negatives at all costs. The institution successfully protects itself from regulatory risk, but it pushes the massive cost of false positives, frozen accounts, denied payments, and blocked access entirely onto innocent users. Calibrating that threshold determines exactly who bears the cost of the machine's mathematical uncertainty. We can see these theories applied concretely in the automated credit decision. Modern lending has shifted from a moral economy of personal, relationship-based evaluation to a scalable, statistical portfolio logic. Under this logic, a cohesive human narrative is disassembled into three mathematical vectors: probability of default, loss given default, and exposure at default. Probability of default, or PD, is the core likelihood of failure, directly dictating whether an applicant is approved, rejected, or subjected to punitive pricing. Because the score relies on rigid proxy variables, it heavily penalizes non-standard lives. A gig worker with a volatile but strong cash flow appears risky simply because their data lacks standard, salaried legibility. These standardized exclusions are executed silently, millions of times a day, across the glowing server racks of the financial sector. Modern credit scoring re-engineers the moral economy of lending into a cold, probabilistic sorting mechanism. It treats the very absence of standard data as a negative signal, punishing those who exist outside its digital vision. This brings us to the most dangerous illusion of automated systems: the belief that the massive datasets used to train these models are raw, objective records of the past. Historical data inherently stores the residues of our previous institutional exclusions, old social hierarchies, and past blind spots. When a model is trained on past hiring or lending successes, it is actually learning past managerial preferences and prejudices, not pure merit. This creates a recursive feedback loop. The system replicates those past prejudices with greater consistency and at a wider scale, disguising the discrimination under the technical banner of optimization. Relying on historical data without rigorous sociological intervention does not predict the future. It simply turns human history into machinery. These standardized systems now govern everything from political audience segmentation to workplace surveillance and dynamic pricing. As their scale expands, they create a massive accountability vacuum when they inevitably cause harm. When challenged, executives claim the model decided. They utilize procedural distance and technical opacity to soften their agency, hiding behind the software when making harsh or discriminatory choices. True governance cannot be a mere technical audit. We must interrogate the system's objective function, its proxy assumptions, and its tolerance for false positives. Machines only decide because human beings first decided exactly how they should decide. We must stop pretending the mathematics are neutral and start auditing the institutional power hiding behind the code.